To ensure the wind playing in the level never stopped and maintained some randomness, I used a number of audio files and different delays within a sound cue. By offsetting the delays on a number of different wind samples and having one much longer wind sample that acts as a main layer for the wind tone. Given some areas of the level feel more open than others, I wanted to have an increased sense of windiness when the player is out in the open. To do this, I created a number of trigger boxes which, when overlapped, trigger another layer of wind to play with a slightly different tone. With the shape of the level, I decided that I wanted to use a spline to approach implementing the sound of the ocean. The idea of using trigger boxes for all of this seemed like it would become quite messy. A more dynamic way of approaching it was by creating a spline that wrapped around the island and finding the closest point to the player's camera on the spline and emitting the sound from this point. As the ocean was a 2D sound, it only applied volume attenuation from this distance, rather than spatialization as well. To create the sound of a group of crickets, I used the granular synth within Unreal Engine. For creating the actual cricket chirps, I applied some ring modulation to a sine wave and added some slight distortion. I then created a blueprint for the granular cricket, setting up the granular synth to play the chirp at a constant rate, effectively looping it. I then set the grains per second of the synth to get its value from the distance between the crickets and the player. Using a map range clamp to convert between range of distance to range of grains per second. This results in it sounding as if there are more crickets chirping the further away the player is and less when closer. I used a timeline to create the effect of the pitch swelling in order to add a little more variation to the sound, with the bass pitch also slightly increasing as the player walks away. I wanted to create the same type of options that middleware like Fmod provides, with scattering and randomizing location and timing of sounds within set areas. I found a very informative blog post that covered how to approach this. To start with, I created a new ambient sound class blueprint for each different bird. These ambient sound emitters were then placed around the map where I wanted to play the sounds from. So although this system is not totally random, as you have to specify which potential locations, it still creates the desired effect. Then, I created a trigger box for each of the different types of bird. By keeping things controlled like this, it prevents too many ambient sounds playing at once or overlapping. Given the other characters on the map, it was important to specify that the trigger box is only triggered by the player. At the beginning of play, all actors for each of the ambient sound classes are stored and set as variables. Then, when the corresponding trigger box is overlapped, a check is performed to ensure that the player is still overlapping the trigger. Then, the macro random without repeat is used to randomly select a sound emitter from those stored previously. This randomly chosen location is then set, and another branch check is performed to ensure the sound is still not playing before proceeding to set and play the bird sound. To create the various roars and growls, I started with recordings of animals such as pigs, camels, lions, and chimps. I experimented with using a vocoder with my voice and different animal sounds set as the carrier. By using my voice to perform the sounds, I was able to create a much more convincing initial sounding layer in regards to timing and conveying the desired emotion. When implementing the sounds for the monster, to create as great a sense of size as possible, I attached the sounds of the roars to the face, footsteps to the feet, pocket rattles to the belly, and weapon swings to the arms. To further reinforce the monster's size and danger, I calculated the distance between the monster and the player. This distance is then used as the x-axis value in a graph to determine the value of the various insect sounds in the level. This results in the crickets and the other insects in the level quietening down when the monster comes too close to the player.